moment to thank our partner, America250, for their support in co-hosting this amazing experience. Lastly, we would also like to remind you to download our event app, eAtlas Adventures to Go, for a fun scavenger hunt and trivia throughout the space. Now, for a panel on artificial intelligence, computing, and software, please welcome Paul Makapetris, Internet pioneer and domain name system inventor, Sudipto Roy, VP, Engineering Qualcomm, Ted Tanner, Chief Technology Officer, Leidos, and moderator Alex Knapp, Senior Editor, Forbes.
Hello. Thank you to everyone for coming. Who's ready to nerd out a little bit? Yes, thank you. No, we can do better than that. Come on. Nerd out. Let's go. All right. So I am very excited to be a part of this panel talking about, I think, the most interesting technology of our age right now. But we're also here to celebrate kind of the history of innovation in America. A fun fact you may not know, but you're going to learn it right now, is that many of our founding fathers weren't just like politicians or lawyers. A lot of them were inventors. George Washington invented agricultural innovation. Thomas Jefferson invented like everything. Ben Franklin, you know, your swivel chairs, like making pens that made copies, everything. Ben Franklin invented bifocals. Like, invention is at the core of the DNA of America. And Sudipto, who is coming to us here from Qualcomm, which you may not know this, but you almost certainly own a Qualcomm product, even if you've never heard of the company before. They make stuff that's embedded in like everything. And speaking of embedded in everything, we were talking beforehand about how innovation is embedded in our country, and you want to talk a little bit about that?
Yeah, I would like to, this is our 250th year celebration. I'd like you to take you back to the beginnings of our country, young nation, war-torn, unsure of its constitution, yet in the first constitution, in the preamble, there is the progress clause that is for the promotion of useful arts and sciences, and in the first legislative act of the Congress, there is the Patents Act.
Yes.
Isn't that cool?
Yeah, because our founding fathers were nerds, people. It's the thing we should remember. So they were awesome people. And as part of this celebration at Forbes, we did our list of America's 250 greatest living innovators. I'm very excited to have one of them with us here, and that's Paul. Please give him a hand. Paul is one of the reasons why you write .com at the when you're looking for a website. He invented the core technology that like enabled that to happen, which seems simple, but it's actually really complicated. And Paul, I'd love to know what is exciting you about innovation in America today, like with AI and all the things kind of happening around that.
Well, you know, the key feature of the design of the DNS was that it didn't envision all of the applications. The web didn't exist then.
Right.
But it was prepared to adopt whatever came its way. So these days we're worried about how we're going to organize AI and how we're going to protect people from AI, because although there may be millions or billions of hackers out there, there's going to be trillions of AI agents, and not all of them are going to be willing to do you a favor. They're going to want to hurt you. So we have to figure out how to preserve our freedom and safety in this age of AI.
Yeah, and Ted, I know that you've been working on AI since like the 90s, basically, across a wide variety of companies and with Leidos today. I think for those who are maybe kind of confused, I think we're all familiar with like chatbots and working with ChatGPT at this point. You tell us what makes an agent and how do we define that?
Yeah, so as I'm fond of saying, it's nothing scary. An agent is a piece of software in and of itself that actually you can have it optimize. The whole concept of an agent or artificial intelligence is such that you teach a piece of software a goal and you have it optimized in and unto itself. So it can actually go off and do stuff like read your email and summarize it, right? And so a lot of people hear the word agent and they think the movie Jerry Maguire, right? It's kind of like that, but nowadays the software is so powerful that you can have, as here at America Innovate, you're going to see robots dancing, you're going to see cars driving by themselves, and the word of the future, hopefully for the next 250 years, is going to be autonomous systems. So it's super exciting.
Yes, and I'm excited for my AI agents to show me the money, which they have not yet. Although I do use them for other stuff, and it's kind of interesting how you can program the AI agents to kind of just do simple tasks. So just to give you an example, as a reporter, I have to interview people. When I interview people, there are like 36 general Google searches I would do to get someone's background, their education. I'd look at their LinkedIn bio, and I would do all these, this, that, and the other thing. I'd look for news about them, look to say if they've done anything controversial. I won't say which of these people have done that, but some of them have. And I've programmed an AI agent that literally does all of those Google searches for me, and it just presents them to me. But one thing that I've been trying to figure out is it doesn't always give me the right answer, so I do have to check them. And so, Sudipto, I'm curious, when we're thinking about the outcomes and what we're doing with agents, how do we make sure we're getting the thing that we want?
Yeah, so agents, like Ted said, are this general purpose software that can do reasoning, that can do planning, that can do tool calling, right?
Yeah.
Now, that's like giving a precocious teenager the keys to your bank, yeah, the keys to the kitchen. She can eat whatever she wants, right? So, but the teenager, she's a very smart teenager, but you don't want her to have unbounded freedom, right? So the way you bound the agent is through have guardrails to check the output. Is that output something valid for the overall system design? So basically, the short answer is don't rely on the agent. The agent is part of a larger system, and learn about systems engineering.
Yeah.
Yeah, and if you think about the terminology, if you think about a symphony, it's called orchestration. So each instrument in and of itself sounds great, but when you're in a symphony, you orchestrate things, and so you have a conductor. And you literally have agents that can be orchestrated to do a multiplicity of things for the operator, where, that's the great thing about what's happening right now with AI. If you think in the history of computing, a big inflection point in innovation was the graphical user interface, and it allowed access for people to do general purpose computing. Well, the amazing thing about artificial intelligence now is it's been going on for a long time. The type of technology actually was originally invented in the 1950s. And we came a long way since then in a lot of different systems. But the main inflection point from a consumer standpoint was that it was provided, the keys were given to the world. So immediately you're able to orchestrate agents for the things that you would actually want to do. And that user interface coupled with giving it out to the consumer is what has scaled things exponentially.
And Paul, I think another concern people have around AI is around like privacy and security. And I know that's some of the stuff that you're working on right now. Can you talk a little bit about how we can manage some of those risks and like use AI for the good stuff and not let bad people do bad things with it?
Well, we're in the early days. So I think what we ought to do is take a look at what we've seen. Right now, a lot of the emphasis on agents is having to do with writing code, because that's what people will pay an unlimited amount of money for, because they get their own products improved by getting code written. I would hope that what we could do is to have similar progress in things like radiology and health and so forth, but the profit motive isn't quite as aggressive there. So, I think what we're going to look for is we're going to look for agents in a couple of niches. Coding is clearly leading today. I think that managing the personal, agenda, as in, I got to get rid of Outlook and have something that's useful in my phone. Okay. Oh, I'm sorry, Outlook doesn't work with my phone. The fact that I can't have a contact list that works between my Qualcomm phone and my Outlook is kind of silly. And maybe agents can do some of those good things. I think that's some of the good things we can look for out of them. But agents also give power to people, and we have like this concentrated power problem that I think we need to look at.
Yeah. Well, if it makes you feel any better, Paul, the Artemis 2 astronauts also struggled with their email programs while they were while they were out there. But you know, one thing, Sudipto, you and I had talked about earlier is, and I think another urgent question is how do we kind of democratize access to AI? And you know, you mentioned some of the things that you're doing to kind of teach people more about how to use AI and how to use it safely. I'd love for you to talk about that a little bit.
Yeah, actually, I have a really cool job at Qualcomm, and that's we run startup incubators in the US and frankly all over the world. And we work with early stage startups, so startups that are post bootstrap, pre-A, because that's the best time for them to influence the technological roadmap. So these startups actually work a lot in the machine to machine area, machine to human area, right? Whereas generally here in Bay Area, you see a lot of work in the human to human area, in the cloud area, right? So in this realm, the devices are quite tiny. It could be your ring, it could be your band, it could be the glasses you're wearing, your phone, your laptop, an embedded device that controls your home, factory, hospital, so on and so forth. So there is a lot of room in this area for engineers to actually design end-to-end systems where AI is a part of it. The AI is not the final dish. Right. It's a part of the dish that can do good predictive work, that can do good reasoning work with the guardrails, right? So in order to democratize this area, what my company has done is, for instance, we recently acquired a company called Arduino. Arduino is a very famous Italian startup who have like close to 40 million developers who can build embedded computers, robots and such, right? By putting AI there, we give it to the hands of such tinkerers, frankly.
Yeah. And speaking of robots, I know at Leidos, Ted, you guys are working on like robotic vehicles, self-driving vehicles, boats, and other types of things. What are the challenges in kind of making those autonomous, you know, bringing that autonomy to physical objects in the real world? And there it's, you know, if my AI agent gets my background briefing wrong, I might have an oopsie and have to issue a correction if I fail to fact check it. The oopsies are bigger when we're talking about like boats. So how do you manage those risks?
Well, yeah, most people know Leidos from walking through the thing in the airport and putting your hands up, right? We do so much more than that. We do mission critical AI systems at scale. So we have a healthcare division, we have a homeland division, we have an energy division, we have an intelligence division that you really can't talk about much, but we also have a
AI secret agent.
Yeah, and we also have a defense division, and the and it's unmanned autonomous vehicles or unhumaned autonomous vehicles, and so we have things that go underwater, we have things that go on the surface, we have things that go in the air and space, and delivering mission-critical systems at scale for national assets. They're literally considered national assets of security. The context of that, the delivery can be quicker, but the accuracy must be exact. And that is very important when you're delivering those types of things at scale. So it is very important that you have some type of human in the loop to fact check the artificial intelligence, because in our line of work, things can go, it can go a certain way, but in most cases, because of the way we deal with mission critical assets, we deliver those national assets in a way that protects the nation.
Yeah. And speaking of protection, Paul, you know, I think one thing you had mentioned earlier, that AI is very good at coding. And another thing, you know, if you've been following the headlines lately, is that it's also good at catching bugs that can be exploited by bad actors and by threats. So when you're thinking about, you know, security and, you know, kind of in this age of AI where someone who really has no coding experience, they can build their own app to do something cool for themselves. They can also build an app that lets them do bad things. So how do we add that protective layer in, and how do we kind of manage that
Well, I think we have to start out by being careful of the responsibility that we give to AI.
Yeah.
You know, the reason that we have self-driving cabs running around here is that we've done some of the work. Now, they have run into wet cement and sunk.
Yeah.
When the traffic lights were out due to a power failure, all of the autonomous cars were wondering what to do because they can't obey traffic lights that aren't on. At any rate, so for the consumer, you know, never mind, you're going to have customer products that are going to be out there that are going to have bugs in them. You should get used to the idea. It's going to happen. So I think what you need to do, both from a standpoint of your own personal behavior and what you'd like your political class to do, is to limit the amount of responsibility you give to AI and understand that along the way, you're going to learn by trial and error. The thing that AI is incredibly good at is doing trial and error at a speed you can't imagine. That's really one of the deep secrets of AI. That's what's going on. It's trial and error at super speed. But, you know, you're going to have to debug some of the stuff. So be careful, you know, what responsibility you hand out.
Yeah, I think we live in an age now where the time from idea to what I'll call maximum viable product, if you ever heard of minimum viable product, is maximum better. We live in an age now where you can think up an idea and have it running in a matter of minutes to check it, right? And I think that, Paul, as you said, that level of time compression is very important, but it also is extremely important for us as researchers to have the ethics and guardrails to say, okay, what does that actually mean for the end user, and have step variations on how it's deployed.
At my work, I tell my engineers that demo, not memo, right?
Right.
Basically, because now we have this coding tools. So if the coding can accelerate, let's say, your workload to 10%, then what are you doing with the remaining 90%? Then writing the security spec, the product spec, like thinking through the design, designing the test harness, right? Looking at customer bugs, anticipating problems. Why was there a test escape, right? So it's almost like, I'll make a comment that a famous CEO who I admire a lot said something really irritating, like people in computer science should stop learning coding. I was like, why? Then you're equating computer science with coding.
Right.
There's a lot of things that engineers learn. This is like back to basics. Relearn to become really good engineers, and those trade-offs that we do.
You know, it's interesting you say that, because I was actually at a conference a couple of weeks ago, and I was talking about at a big software company, talking about AI for coding, and they said the great thing is now, like, all of our teams can make apps. The bad news is that none of them are up to production standard, and our software engineers are working overtime trying to get them up to that level. So the bottleneck shifted from having to design this and get the software engineers to do the baseline code to having to design this and getting, you know, basically taking this lump of clay and actually turning it into a usable product. And I'm curious, is this what you guys are seeing too? And
Absolutely. I mean, at my company, we are one of the top 10 users of Anthropic, right? But all the code that we write, it cannot be predictive. Like entire lives, like Ted said, mission-critical systems depend on it, right? Your phone cannot sort of work. It has to work, right? As an example, your health monitor cannot sort of work, right? So kind of what I said earlier, AI will fit into part of your engineering workflow, and you have to be, if you start thinking of AI as replacing an entire workflow, that's where you get into trouble, like Paul said.
Yeah, I mean, and one of the things is that you can have a human in the loop with, you know, Department of Defense drones, but not the brakes on my BMW. You know, you know, and so we're going to be deploying AI in a lot of places, and you know, I think you just got to get used to it, and you know, the future is unknown, and people who say, well, what we can do is figure out how to make this 100% safe, and we know that what the future is like, well, they're wrong.
Yeah.
Okay. So, you know, one of the things that we do is we try and figure out how to compartmentalize the scope of how particular AI is used. one of the demands my company gets is people say, you know, I think I have some engineers running wild with Anthropic doing their work for them. I'd like to detect that and stop it. You know, it's not because Anthropic is bad. It's just they're going like, well, we don't believe in AI, or we use brand A rather than brand B. So one of the things is shaping access to AI is something that a lot of companies are thinking about, because they don't necessarily want all their intellectual property being sucked out by AI.
Right.
And that's why, you know, I think there's a lot of promise about when you start thinking about doing AI in your phone or in your laptop, rather than off in the cloud somewhere in outer space with Elon. You know, you at least can put a boundary on where your information is going or leaking, depending upon your point of view.
Yeah, I look at it like, well, once again, mission critical systems. Time to check an idea, time to analyze data quicker, and time to make a decision in context quicker. And the context is really key. And so that it's a tool, right? You know, it's a tool to do things quicker with better context. And, you know, I am very pro-human, and I believe that the human ingenuity and the human creativity is always going to outrank all of these other things, right? And so, because as soon as we think we figured out, as technologists, we figured out how something might be used, somebody comes up with a whole different use for it. And so that's why I'm proof positive on what you were saying, Paul, about the future.
I have the privilege of working with some brilliant minds in our country and around the world. In this age of AI, where there's a lot of agony about losing jobs and such, I'm actually seeing the spark of human ingenuity applied everywhere. Agri-tech, healthcare, smart industry, everything, right? Engineers, scientists, researchers are figuring out how to use machine learning. This is the golden age of machine learning. We are fearful of generative AI. Machine learning, which is detecting images, sound, is actually
I'll put a fine point on that. I'll say the nerds and the geeks have won, and we're pretty happy about it.
So, Paul, do you want to give us a final thought to bring us back? Because you've been part of this world for really a while now. So how do you kind of see the vantage? What are you excited about for the future?
I think you got to be scared, but you got to get up in the morning and go about your life. Yeah. I think that's my bottom line. And I think that the AI story is going to be fantastic, and I'd rather worry about it than biohacking, which is something that really scares me.
Well, that's something that'll probably actually come up later. If you guys stick around until about 2 o'clock, we'll be talking about biology and healthcare. So please do stick around. So any other final thoughts, guys?
We live in an age now where it is possible to build the impossible. And so what I tell everybody is go get the tools, execute on brilliant ideas, and go make a dent in the universe.
That is a great message to leave us on. So thank you all so much for the panel. Thank you for being a great audience. You were awesome. Thank you.
Now, for welcome remarks, please welcome to the stage Alex Knapp, Senior Editor, Forbes, Kristen Thompson, Deputy Executive Director, U.S. Semi-Quincentennial Commission, America 250, and Ted Tanner, Chief Technology Officer, Leidos.
And I'm back. You all should be very thrilled about this. So I want to welcome you all to the America Innovates 250 event. We are here celebrating the 250th birthday of this country, which I dare say is the nerdiest country in the world. We have created the greatest nerd products from computers to robots, and you're going to see all of that here, healthcare. But innovation is more than just, it's more than just science. It's also that kind of spark of putting that idea into the world. So I actually edited our 250 Innovators package, and it isn't just all scientists and technologists. When we were looking at history, we looked at people like Lucille Ball. And you think, how is Lucille Ball an innovator? I'll tell you how Lucille Ball is an innovator. She invented the 3-camera sitcom, which is like how most sitcoms are produced now. She invented putting sitcoms into syndication, which is why we're all still watching Friends 30 years later. She, when her studio was like, we do not want to greenlight these two properties. Those two properties were Star Trek and Mission Impossible. And she said, no, I think we should make those shows. And those shows are still being made today, and Tom Cruise wouldn't have a job without Mission Impossible. So Lucille Ball, you can thank for that. That is a type of creativity, innovation, entrepreneurship that we're celebrating here. We have a lot of cool stuff for you to see. We've got the Joby aircraft outside. We have all kinds of cool healthcare stuff up there. We have an AI avatar for our Innovators 250. We have robots that you can punch. It's really going to be a great time, as well as all of the program that we have. So with that, I will leave it to our other folks.
Yeah, so Ted Tanner, CTO Leidos, it is very humbling to be on the America Innovate 250 stage. And I had the experience last week to go to Monticello, where Thomas Jefferson's home was. And, he just wrote the Declaration of Independence in 3 days, that thing. So I always ask people, like, compared to that, what'd you do today? Don't feel bad. In his home, he had so many things, like the double pane glass window. That was one of the first. He had a writing machine that used 2 pens, quill pens, so he could write documents quicker. Okay? He had a device that actually suck the air out of a dome so he could test vacuums. These things are innovations that we really don't think about, but it is part and parcel of America's history. So if you think back in time, like we talked about the patent system, right? And we talked about media. Media is huge. That is a national asset in the United States, is our media assets. That is considered a national security asset. So if you think about the way that we as Americans innovate, there's so many firsts, and it's great to be here in Silicon Valley. I call it the 33 miles of the universe of innovation. Okay, like there's so many firsts compressed into this 33 miles. But nowadays, since technology is proliferating, we have it in our pocket, we have it on a screen, we have the power of the internet that Paul helped invent, the DNS. Well, now we have this knowledge discovery and ability to scale your innovations like no other, and the ability for ideas to actually turn into physicality and make new things has been unlike any other in the history of time. And it is truly, truly astounding. As somebody who's been doing this a long time, I can tell you, when you're looking at technology and you finally see it working, you go, my gosh, it is actually working. It is amazing to see. So please, as you walk around and see all the great innovations, please think about what you can go think up and build. Thank you very much.
Thank you so
Before
much.
Kristen speaks, I do want to say, so you don't feel too bad about yourselves with respect to Thomas Jefferson, fun historical fact, he brought macaroni and cheese from France, and from all of his contemporaries' letters, he made the worst macaroni and cheese you've ever had. So if you can throw together a decent mac and cheese, you at least got that on Jefferson. So I'm just going to say.
All right. I don't know how to top that. Thank you so much, Ted. I'm Kristen Thompson. I'm the Deputy Executive Director at America 250, also known as the United States Semi-Quincentennial Commission. So try to say that very, very fast. So the number of the day will be 250. You're hearing about the Forbes 250 list. And when Randall Lane came to us and said, hey, we should partner together. We're going to list amazing innovators. One is right here in the front row, Dr. Springer. We're so grateful for your partnership and leadership on all things innovation. He came to us and said, we should do something together. And I said, amazing. We're going to kick off America Innovates with our founding innovation partner, with Leidos, and he said, let's do it together. So we really believe in sea to shining sea. So we're going to start here in San Francisco, as you mentioned, in the 33-mile that has now spread across the country, and we're going to end in November in Washington, D.C. with our second expo. And so this is really what we call the movement at America250. So we have amazing programming that's been going on for the entire year, and we will go through the entire year of 2026. Today, also happening, I want to highlight, we are actually doing Good Neighbor Day America, which is going across the country, spreading 250, again, that number, million acts of kindness. So we have our commissioners on the ground in communities. There are things happening all over the state of California. LA is a big event for us, and we want to make sure that we're capturing the largest number of volunteerism hours ever recorded by one country this year. We have many more programs. So you mentioned Monticello. We also have a civics education program where the kids actually got to see that firsthand. So bringing all of these things together is what I get to do every day, and really just highlight all the incredible work that everyone else is doing, and I get to say, hey, isn't this great, as we celebrate America's 250th anniversary. So we are so excited for that movement to continue, and we will also have a lot of moments that will come through as well, and that'll be highlighted on July 4th, as hopefully we're all celebrating, whether that's in your backyard or in LA at the Coliseum, where we're going to have America's Block Party. But one thing I wanted to leave you with is there's only one thing I have to do by law, and that's to bury a time capsule in Philadelphia on the morning of July 4th. I unfortunately will not be there. I will be in LA coming back here to California, but it will be lowered into the ground. And part of that was we thought, how could we make sure that people feel included in this process? So we opened up a White House Visitor Center exhibit where you can see all of our programming right in Washington, D.C. And we said, we're going to ask people what they think. So I thought it would be fun to bring some of those ideas here. This is literally people that are coming through, dropping it into what we have as it's not the real one, but the cylinder device of ideas. And it says, what innovations do you predict for the next 250 years? So I did not get through all of them. We've only been open since April 1st. There are hundreds of them. So going through all of them is going to take me a little bit more time, since I just got them this week at our commission meeting in Philadelphia. But I thought it would be fun to read a few. And I don't know some of who the people are, right? Sometimes they just write their idea and not their name. So this one is an 11-year-old girl named Edith from Seattle, Washington. And she said that there will be flying cars, which was a thematic across a lot of them. But she also added that she wanted to have Band-Aids that don't hurt when you take them off. Seems like an easy idea.
I would
so
also like those.
Hopefully someone can take that back. Time travel was also one that I think was a thematic that ran throughout. However, the second thing that they added was how to fold a fitted sheet easier. Has anyone watched a video on that? I have. Still can't do it to this day. So how do we invent a sheet that can go on very easily that we don't have to fold when we put it back in the linen closet? Food that can taste like anything you want. I have picky eater kids. I think that I would welcome that, right? Anything I put on the table should be eaten and well taken. And then this one from Catherine, age 8, she said that she would like blood testing that doesn't require needles. Not sure how we can do that, but if anybody has any ideas, let me know.
Looking at Tim.
And then the last thing I'll leave you with is that everyone can see the past and the future. And I really reflected on this one because I think we don't always love the element of surprise anymore. We like to know what's happening. And so maybe this is good, maybe it's bad. We're bringing that together, I think, right now to kind of think about how we're paving the way for the next 250 years. And that's what we're here to do today. So we welcome all of you. Thank you for coming. We're going to be here for 3 days. Each day has different programming. So don't just come today, come tomorrow. Tell your friends and your family. We are so delighted and excited to be here and partnering with Forbes and Leidos and all of our partners and sponsors. And last thing I'll plug is eAtlas. You heard it in the beginning of the panel. Download that app. They've made a fun scavenger hunt to make it a little bit more interactive as you go throughout the exhibit today. So thank you all for being here.
Now, for welcome remarks, please welcome to the stage Arun Gupta, President and CEO, Noble Reach Foundation, and author.
"250 years ago, the greatest entrepreneurial venture, arguably, in human history began. Founders came together, signed a document, a definitive agreement called the Declaration of Independence, and with that, we launched the venture of America. Think about what that actually was. A small team, an audacious vision, an unproven model, enormous risk, no guarantee of success, but it was with an absolute refusal to accept the world as it was. That's the entrepreneurial spirit. That's always been the American spirit. And that's what's always differentiated us from anywhere else around the world. And every breakthrough that has followed, every drug, every technology, every scientific discovery that has changed how we live has drawn from that well. Over decades, however, we started to silo our competencies, where they no longer interact and collaborate to solve big problems in the way we need them to. Government, academia, industry, not-for-profits. I've spent my career living across these divides. Public service was in my family. My father was in the Navy for over 40 years. My professional career was in venture capital. I was backing founders that were betting on those same kinds of dreams of being able to accomplish what seemed impossible. I started teaching then in academia and was working with the next generation and realizing how many of the researcher and great talent that we had were still not interacting with government or industry in the way we needed them to. And that was what led to us creating the Noble Reach Foundation, a foundation that we have today with over $500 million endowment, looking to bring these three sectors together to solve big problems. And in each of these chapters, I kept running into the same issue. The researchers who would stay in the lab but didn't know how to bridge public and private interaction. Entrepreneurs who didn't realize their technology could have massive implication if collaborating with government. And government agencies that, in trying to solve our largest societal problems, weren't able to get the top tech talent they need to come in. These silos, however, are not inevitable. They're a choice that we keep making by default over and over and over again, and we can make a different one. And that's why we've started Noble Reach. We've been around now for 3 years. We have two core convictions. One is around talent. We need a community of what we call dual citizens, public, private sector citizens. Citizens that understand the language of both, that understand the networks of both, and the cultures of both. And the reason that's important is that those same citizens are the ones that can bridge trust amongst these sectors. And I think we all look around and we can see that these sectors today suffer from a trust deficit. Two, we must modernize that infrastructure and connect it to talent in a much more meaningful way. So at Noble Reach, we do exactly this. We have talent frameworks that we now think Teach for America, bring our best and brightest into government, coming out of school, top AI, cyber bio students. And we also foster innovation in the work that we're doing with DARPA and NSF. To date, we've helped spin out over 100 research teams into ventures that are now solving some of our biggest societal problems. Building these bridges is essential for our innovation ecosystem. And we talk about this in a book that recently just launched called The Mission Generation. It's available upstairs, and we'll do a book signing for anyone interested after the talk. But at the core, it's how do we take civic responsibility and personal ambition and not make that a binary choice, but make that an integrated career. The most powerful thing we can do right now as a nation is to bring these two forces together. And the mission generation isn't about age, it's about agency. My dad had one job for 40 years. I had one career, multiple jobs, and it stayed in my lane. Going forward, we're going to have 4 to 6 careers for 60 years. And we don't have the scaffolding to support that. And currently, our structures support prestige markers, pathways that are built for a stable environment, who we work for and what we do. Going forward, to navigate the constant disruption, we need to be building careers about what problems we care about, which is much more of a purpose marker. And these old scripts are being rewritten real time. In the world we're moving into, that same stability that we've built structures for are now our biggest risk. We argue that stability is the new risk, and the moment demands an entrepreneurial mindset, a mindset that is about how do we create new pathways, how do we create a more experimental mindset, Not wait for clarity to act, but act, and then let that bring you clarity. In the moment we're in with AI, I think that AI helps us bridge these silos. Because today, as people are locked into these and trapped in these silos, what AI does is go after IQ over EQ. And with that, we can now focus on a new set of domains that will be important for skills. Versus what you know, it's the experiences you have, experiential capital. It's the relationships you have, trust capital. It's the impact you're having, which will be incredibly important. It will be your curiosity, which is learning capital. These are all things that will be incredibly important in the world of AI that we underestimate today, and we talk about this. And at the end of the day, this is not a startup philosophy. This is the philosophy of our country and what we've been based on. And 250 years ago, I would argue that the founding fathers created a system of independence that we've all benefited from. And the challenge now for the mission generation is to create a system of interdependence. And so with that, thank you very much.
Now, for our special panel, Scientific Breakthroughs, please welcome George Church, Aging, AI, Reading and Writing, DNA, Tech and Author; Kuleni Gebrez, Vice Chair, Life Sciences and Healthcare Industry Leader, Deloitte Consulting; LLP, Suma Krishnan, Founder and President, Crystal Biotech and Moderator; Alex Knapp, Senior Editor, Forbes.
I need walk-up music. I have words. How's everyone doing?
Hello.
Good. I hope we're all excited to once again nerd out over science and technology. Can I please get a cheer for that? Nerding out! Yes. Thank you. So way back in the day in 1790, when the first patent was issued and it was signed by George Washington himself, that invention was an ingredient for fertilizer used in agriculture, because life sciences are a core part of American history. In fact, George Washington, during the Revolutionary War, he was the first general to ever have his soldiers vaccinated for a disease. They were inoculated against smallpox. Way back in 1777, and America's been at the forefront of healthcare and science ever since. So in that vein, I'm very excited to introduce Mr. George Church to you. George has done everything from dissecting woolly mammoths to making it possible for a pig kidney to be transplanted into a human being. So George, I'd love to start with you. What's exciting for you about this moment in life sciences?
It's extremely exciting, in part because we have exponential technologies, things where we've brought down the price of the human genome from $3 billion to $100. We've then applied that to in vitro fertilization clinics, where we've helped reduce the cost and the lowered the pain for the injections. We have, you mentioned the transplants that are working now in real patients with kidneys and liver. And aging reversal, I think, is extremely, we've done this in preclinical trials where we've actually doubled the lifespan from the point where they were already, half of the animals were dead.
That's very cool. I look forward to being around for America 500 then. So
count on it, yeah.
All right, and Suma, I'd love to talk to you a little bit about the work that you're doing with gene therapy, because I think it's different when people talk about genetic therapies and fixing genetic disorders. Your company has a really unique approach to that, and I'd love for you to tell people.
Absolutely. I mean, and many of you guys remember when gene therapy, when the first patient was treated with a gene therapy product, the patient died because people didn't understand putting a virus into a human and the safety and toxicity. Since then, 20 years fast forward, gene therapy is the in thing, especially for treating rare diseases where you have a genetic mutation. And the only way to correct the underlying disease is by replacing or substituting that gene so you can make the protein that these patients don't produce for them to bring back the function that protein does. So it was very interesting. I mean, if you look at gene therapy, it was mostly done in a clinical or in a hospital setting where you have to basically administer the gene as an IV systemically. But when I started looking and studying at different diseases, what I saw is like skin. If you look at skin, it turns over. So you can't have a systemic gene therapy for the skin because the proteins that are produced by the skin are like big proteins, collagens, there's 22 different collagens. And these collagens are produced at the skin level. So you have to have a therapy that is at the skin. So there's a disease called epidermolysis bullosa. I mean, many of you may not have heard of it. Hopefully, it causes more awareness. It's called the worst horrible disease, the most horrible disease. The reason is because these kids are born and they're missing skin. When they're born, the parents are like, what happened? Why is my kid missing a skin? It's because they have a mutation in a protein called collagen 7, which is responsible, the protein produces these hair-like fibrils that basically stitches your epidermis and dermis together. So you can imagine when you don't have this protein, your skin starts sloughing. So for something like this, we had to come up with a solution that was going to be topically. So what we developed is a topical gene therapy. We used a virus, a herpes virus. I know people get nervous when they see herpes virus, but trust me,
it's fixed. It
it's
doesn't
fixed.
hurt. Yeah.
We engineered the virus to make the virus replication incompetent, took all the bad parts of it. We were able to put the collagen 7 gene, basically formulate it into a gel, and these patients have open wounds. So we apply it on the open wound, and as the skin closes, because the skin will close, but it keeps opening back again because it doesn't have the structure to keep the skin together. So what happens is as it closes, because we're able to put the protein, it corrects the skin and it improves the skin texture and the quality of the life. I mean, I'm making it simple, but if you guys Google and look at this disease, horrible disease.
It's honestly almost like magic. If you can imagine someone who has, their skin isn't fully coming together, they apply Suma's gel, and over the course of time, it heals them. It's like when you watch a movie and someone, it's hurt or whatever, and they drink a potion or whatever, and they're suddenly better. Right. That's literally what she's doing. She's turning science into magic, which I think is awesome. And I think it's just remarkable what you're doing.
Thank you. And it's approved. Now the product,
yes,
the drug is approved, not in the US. I mean, this is a small population, 2,000 to 3,000, but globally it affects 15,000. Now the drug is in Japan, in Europe, and rest of the world. So it's, to see it in practical and changing patients' lives is so gratifying.
Yeah. And what's great about it is because it's topical, patients can care for themselves and they can take care of themselves. Right. You don't have these kids having to spend all their time in the hospital or hooked up to tubes and all of that. You got to have command of your own healthcare, which I know, Kalani, taking command of your healthcare and using technology to put the patient kind of in the front seat of their own care is a big part of the work you're doing. And I'd love to hear a little bit more about that.
Yeah, Alex, for those I don't know, I'm a physician by background, now in the business world, but also really important, a consumer of healthcare and a caregiver to a son that has type 1 diabetes. But it's been a while since I've heard somebody talk about epidermis and collagen 7, so I'm really jazzed. And what I will tell you is that as a clinician, you would walk into a room and look for a diagnosis that you could treat a patient. What the data actually shows is that for most drugs that are out there, they work for 1 out of 5, sometimes 1 out of 25 patients. So that means in a day, if you see 100 people in a week, 25 to 30 of them will do really well with the drug you give them. 40 to 50 will get a little bit better, but Another 20 to 30 won't get any benefit. And then 5 to 10 will actually do really badly. They will be harmed. So as a mother, as a consumer, what I always think about with AI is that it takes you out of waiting in a waiting room and living in a waiting room, waiting for someone to help you, to being at home and having that device in your phone that allows you to monitor what's happening, to know what to do about it. And then when your doctor or your clinician talks about what to do at home, you can actually go back and say it to me in language that I can understand. And that could mean language other than English or non-scientific language. So, Alex, to me, the most exciting about scientific breakthroughs is it's an N of one, so it works for you.
Right.
And what works for you may not work for me, but I will find something that works for me. And I'll be empowered to actually take action to make myself live longer for America 500, as you mentioned.
Yeah. And a pro tip, by the way, if you want to get epidermis in college and into your regular life, find yourself on the skincare TikTok, and it's all you'll hear about. So, but George, I want to go back to something that you said earlier, and the work you're doing with IVF, and I think fits right in with this idea of taking command of your own healthcare. If you know people who've gone through IVF, these are people who desperately want to be parents. You sometimes have to spend tens of thousands of dollars. You go through a round. It's painful for the expectant mother, and they can go through months of this, and then nothing happens. And then they have to spend all that money over again, go through the process again, and still sometimes nothing can happen. And I'd love to hear about the work you're doing to improve this process and make it better.
Yeah, right. So wisely, a while ago, they stopped implanting multiple embryos because people were having quintuplets and larger. But that means that the one that you implant has to have a low chance of abortion, spontaneous abortion. And usually the people in an IVF clinic have had some kind of problems even before they got to the clinic. So what we did with Gameta was we made it so that even if the eggs are immature, we can mature them and actually get away with much lower hormone doses. Then looking at all the embryos that could be implanted to pick the one that has the lowest probability of failure can result in you not having to come back. So we do complete genome sequencing. I mean, this is something that was a miracle that we could do it for $3 billion at all. And now we think of it so routinely that we do 10 embryos. So yeah, I think it's becoming a more and more common. I think 2% of births today are by IVF in America, and there are even higher percentages in other countries too.
What kinds of success rates are you seeing? Being able to do this and pick kind of the ideal embryo.
Well, there's no ideal. You're just trying to pick the best of the set that you have, and usually you're avoiding either very serious diseases that will kill the child within the first few years of life, or some of them will actually kill the embryo before it even has a chance.
Right.
But yeah, the success rate is close to 100% for the genes we know. But it turns out you can guess a little bit because the consequences are that you'll just get whatever the best is with our current knowledge, and it's better than not knowing at all. Yeah.
Alex, George, as you think about the number of people who have different access to information, that also goes to physicians, right? So imagine there are over 30 million publications that are talking about scientific discovery. Every day, over 3,000 new citations that come out of new discovery. And clinicians generally have less than 30 minutes a day that they're actually reading up on all of these great things. And so what's truly exciting for me in this age of AI, where sometimes people worry about, am I going to lose my job? Are we going to be replaced as humans? The care that you're talking about actually gets to the bedside of every room and on the telehealth on every virtual platform that you have. So I love what you were describing because it's talking about how families are impacted and how clinicians are now empowered to go from being kind of just like human, trying to be superhuman, to having the superpower to make lives better. So it's really exciting for me to hear you describe that.
Yeah, I know other doctors that I talk to also love using AI to help them with their notes. Because if you know any doctors, they'll work a full day seeing patients, and then they spend almost another full day just writing up all of the care notes and visits and things like that. And there are tools now with AI that let doctors kind of speed up that process. Even while they're talking to the patient, the AI will listen in and it'll just start filling in the forms for them, and the doctor can just go back and check later. and it's such a time saver to let them actually read up.
Yes, yeah.
Have more than 30 minutes to
Less
read up on
screen
what the
time,
best care.
more face time.
That's exactly right. Less time on the laptop, a lot of the talking to you, that kind of thing. So, Suma, I would love to learn about, with the work you're doing in gene therapy and having these more accessible therapies, what other diseases is your company working on right now?
Yeah, I mean, obviously, with the skin, there are hundreds of skin diseases. It's not just the one that there is other skin diseases called Nethertons, and there is a lot of other different skins. So we can do the same concept because we've already shown that it works, and we have made it practical and commercialized it. So plug and play for some of those diseases. But again, what we found as we started working with our virus and our vector, we're not limited to just using in the skin. So we can also use this vector in a very non-invasive way to directly put it into the lung. So cystic fibrosis is another disease that we're working on. Most of you guys have heard of cystic fibrosis because there are medicines for this particular disease, but again, there is a subpopulation of this patient population that the existing products don't work on because these are very severe patients. So a gene therapy is something that makes more practical sense. A lot of people have worked on gene therapies for cystic fibrosis, and it's a little bit complicated. But our virus, again, with our vector, you can just nebulize it. So we have a study in the clinic where we have shown some very good, exciting preliminary data where we're able to put the CFTR gene into the vector, and then you basically nebulize it directly into the lung, and that's where the protein is produced, which helps with alleviating the symptoms of the disease. So we're not just limited to the skin. We're exploring non-invasive gene therapies in the lung, in the eye, and other indications where such an approach can be easily applied.
It's amazing. And it's just cool to think about turning viruses, which you think of as causing disease, into medicine, which I just think is the neatest thing.
It's a very interesting point because we were developing this this vector during the height of COVID.
Yeah.
So you can imagine there was a lot of sensitivity of the virus.
Right.
And with our approach, we had to treat the patients weekly. So it's impossible for the patients to come to the clinic. It's just burdensome. So you can imagine we worked with the FDA, the regulators. We were able to really make this a home therapy. So basically now we can ship the virus to the patient's home. We have the safety protocols, and they can administer it themselves at the patient's home, which was very revolutionary.
Yes.
Never done, and this is the only product that has ever been to date in the market that can be shipped to the patient's home and been applied by the patient.
Yeah, that's just amazing. And then another, talking about amazing things that we're doing in life sciences, George, I know another one of the things that you've been working on and involved in, we actually talked about it a couple of years ago when the first successful transplant happened, is actually taking and genetically modifying pig organs for transplant to help people because there's a shortage of organs available from donors for donation, and we can actually kind of help bridge the gap that way. And I'd love to talk a little bit about that work.
Yeah, it's actually another example of gene therapy in a way, where we're doing genetic manipulation of the pig. Right. 69, so that's a record number of changes in the genome, 69 different genes. A lot of them had to do with viruses inside of the pig genome. These are not viruses in the air, but in the DNA of the pigs. That the FDA was very concerned that those would get into the patient and their family because the patients were immune suppressed.
Yeah.
So one of the other things we'd like to do is we haven't done this yet. We do have patients that have the pig organs, but we'd like to make it so that we don't have immune suppression, because all of it is better than living on kidney dialysis.
Right.
But we can make it so that they're both off dialysis and off immunosuppression would be a goal.
Yeah, and what I like about that is that it's also a bridge. Like right now, it's not permanent, but someone might live a couple years longer to the point where they can get a transplant,
right,
and then move on. And Kaleni, I know.
And in the case of liver, actually, what could be a bridge turns out since the liver regenerates, you can then take the pig liver out. You don't have to worry about being rejected because you've helped the. But you've helped the natural liver, and that actually happens. But the thing is, this was not guaranteed. But, yeah.
Well, today I learned the liver regenerates like that. So I always love it when I learn something on these panels. So I hope that. And, Kalani, I'm curious, this is also, we've got AI being used in software to help people, but this is also kind of a golden age of medical devices. Like just new technologies to help people. We were talking a little bit about this before. Can you talk about some of the devices in medicine that you're excited about?
I mean, Alex, there are so many incredible devices, and I love the work that you all are doing from cell and gene therapy, which if you think about it, a lot of these therapies are after you get a diagnosis, right? So imagine the cost to try to cure someone after they are sick as opposed to ongoing monitoring, wearables. So that's everything from a watch, a ring you might wear, to your toothbrush. I don't want to go into anybody's bathroom, but to the toilet, that are able to detect early signals of something about to go wrong. Now, once again, to get personal, my son has type 1 diabetes. He required hospitalization when he was diagnosed. But there are so many signs, there are so many signals that your body releases before you actually get the diagnosis. So Alex, as we're talking about platforms, we're talking about new ways of understanding why your heart rhythm is about to go wrong, why your heart might actually stop, why your metabolic disease and your high blood pressure is going to cause a heart attack or some type of event. And so what a lot of companies today are doing is not just developing the devices to monitor you at home, in the hospital, on vacation, but also aggregate the information, and the computational power is so large that we can predict. So we've got hospitals predicting who's going to get sepsis hours before the patient actually gets sick. We've got diabetes being defined before you get the illness. Yep. And so when you think about that at large scale, that means not only do we live longer, but we spend more time of that life in a healthy space. And so to me, that's a promise that we can all sign up for, and a promise that we should all really get excited for.
Yeah, it's very cool. I've actually spoken to some companies that are in cardiology using this too, where there are some doctors with, everyone's got kind of a distribution of hearing. So there are doctors who can take a stethoscope and really tell something's wrong with your heart because they have exceptional hearing, and some doctors don't. And they've actually kind of used that guidance to train AI algorithms so that you can have an electronic stethoscope and it can detect bad murmurs in the heart, before your doctor might, just because your doctor can't hear it yet. And so, and the earlier, you take care of it, the better, which I think is just a remarkable thing. But also an interesting application of AI. This is a less sexy application of AI. But Suma, we were talking about this before. You have essentially a small business,
correct,
in kind of the grand pharmaceutical scheme, making your thing, and you're using AI to actually improve your manufacturing processes and making the medicines cheaper and more accessible. And I'd love to hear about
Absolutely, yeah. I mean, we are more at the practical levels.
Yeah.
I mean, obviously, when we did our first biological application, it was a very painful, long process because you're building the systems. So if you look at Crystal Bio, we are a completely integrated company. That means we have manufacturing, we release it, we test it, we ship it to all over the parts of the world. We do all our regulatory filings, our clinical studies, so it's fully integrated. And we have systems across the different operations, and they don't talk to each other, and it's very painful. But when you have a clinical data with a positive outcome, then you know you have to put together what is called a biological application, and that can be millions and millions of pages, millions and millions of documents, millions and millions of, and all has to be QC'd, quality control, and it can be right now it's very painful, like each systems don't talk to each other. So we are looking at AI to see how we can crosstalk across the systems to minimize errors, to make life of people easy. Smart scientists should not be spending hours of time QCing or looking at documents and accuracy. This should all be automated. So that's what we are putting efforts on. So we are hoping for our next application we can cut our cycle time by 6 months. So hopefully, that can speed up filing the application. I know 6 months is huge when you talk about getting a therapy to patients that need it right away. So again, we are very excited to put it to practical use. I think it's more doable, and hopefully we'll see results from that.
And Steve, I would actually share with all of you, we work with life sciences and healthcare companies as Deloitte. We've been able to do that, and what you say is actually the mantra that's run in the head, which is the patient is waiting.
Yeah.
So we've taken processes that take 2+ years and millions of dollars, because every month not actually going to market, it also is very costly, and reduce that to weeks and a few months as opposed to months and years. And so what excites me really is that we've talked about what the future of health will hold, and the future is here. Right, so it's here today. And Alex, this is really, I'm sure, an exciting time for all of us as we think about that.
Really is. And a final thought from George I'd love to talk about, because you're also using AI. We were talking about using it early on in the process of drug discovery in the design phase. If you want to just speak to that for a minute before we get it going.
Yeah, so AI is good for everything we've talked about so far, but one of the things it's really great for is designing proteins, which are some of the most amazing drugs already without AI, and now with it, we can, for example, we can design a capsid so it can do very specific delivery to the cerebral cortex. 99% of those cells will then express it. That's something that came out of it. And not only bring down the price, but also, and it brings down the time and safety, because if we have a better track record for safety, we can get these things approved much faster.
That's great. I love the idea of better, faster, cheaper medicines. I hope all of you do too. And that is unfortunately the end of our time right now, but I do want to thank all of our panelists for doing an amazing job. But don't go anywhere. I'll be right back, and we're going to nerd out a little bit more. So stay tuned.
All right. Thank you.
Now for a special fireside chat, the antibody revolution, research therapeutics and me, please welcome Timothy Springer, biotech founder and investor, and Latham Family Professor at Harvard Medical School and Boston Children's Hospital, and interviewer Alex Knapp, senior editor, Forbes.
I told you. Didn't need to go anywhere. So thank you all so much for sticking around. You're in for a real treat. I'm here with Dr. Tim Springer, who is behind. If you go up and actually walk along upstairs, after we're done, don't do it now, but after we're done, you can go up and you can see all of the remarkable things that his research has accomplished in terms of medicines, as well as many of the research scientists he's supported over the years, both in his lab and through investments. And so really, I walked through it last night when there weren't any crowds, and it was a really remarkable thing to do. So I'm delighted to talk to you here, Tim.
Thank you. It's really exciting for me to be here and contribute.
Yeah. So a lot of this conversation is actually going to be, if you'll pardon the expression, kind of a love affair between you and antibodies. So, which have really defined the trajectory of your career, and starting way back in the 1970s, right? So I would love to maybe start off, I think people kind of have a vague idea of what antibodies are, but maybe you could talk a little bit about how they work and you know, how they kind of work as medicines, which I think people don't quite realize that they do that sometimes.
Right. Well, we all are familiar with vaccines. We get immunized, and those are designed to produce antibodies, which are made by a kind of cell in the body called a B lymphocyte, and they recognize things that are foreign, which is pretty amazing, you know, that because there's so many things out in the world that are foreign, but these antibodies actually don't just recognize foreignness, they recognize very specific foreign molecules. And then they will bind to those molecules on a virus or a bacteria, and then they're recognized as opsonized, as coded. And so that code, this antibody binding codes those cells to be killed. by other cells in the body and eliminated. But people realized that this is a great tool that the body has, and scientists can use it. So then they started for their research to immunize with whatever thing they were working with. And they made an antibody to it, and then the antibody became like a new research tool. If you think of microscopes, we look at things with a microscope and we see them. And actually the antibodies is really the main tools we use to see many things in the laboratory. If you go into almost any laboratory, you read any scientific publication, they almost involve using an antibody. And sometimes actually you do see things with the antibody because you make it fluorescent. And then you can pick up that fluorescence in the microscope and you see colors where the antibody is.
It's cool. If you've never done it, highly recommend. If you get a chance to get a microscope and some fluorescent antibodies, you should totally take the opportunity. So yeah, but I love it. Antibodies they're like the scouts of the immune system, kind of like identifying the threats so that the rest of your immune system could go in and take care of business, right?
Yeah, they mark things for destruction.
Sure. And one of the early things in your career, and I think for a lot of people, they probably first heard this phrase during COVID, which is monoclonal antibodies. And those are because that was one of the first treatments that became available that was approved for use by FDA. And so can you tell us what's a monoclonal antibody and maybe where you're seeing one that they don't know about?
Right. So the antibodies are made by cells, and each kind of B cell can make a different type of antibody, and these antibodies can recognize, say, different proteins on a foreign cell. They could recognize different parts of that foreign protein. And before, people were just immunizing, and then they had a mixture of antibodies. You take a blood sample, and then that blood sample has a mixture of huge number of different types of antibodies to different proteins. But then Cesar Milstein discovered that if you took the cells out of an immunized animal and then you immortalized them, so you could grow them in culture, then you could get these cells, individual cells, and you could grow them up. We call it a clone. Each clone is different. And it had a single specificity, and that was a huge advance.
So you're basically taking, like, if you imagine your body produces like a team of scouts.
Yes.
And you're scouting them, like, that's the best guy, we're going to make copies of him and do that. That's the idea?
Well, it's like maybe if your body made a scout that recognized, different, like a tank or a artillery piece or a soldier, those scouts, you can make lots of scouts that just recognize that artillery piece.
Gotcha. Yeah, that is fascinating. And so when we're talking about these, this is used a lot, and I think people don't realize this, for cancer and other diseases.
Yes.
So can you talk about how this works in cancer? Like, how are we fighting cancer that way?
Yes. So in immunology is highly regulated. Most of the time we're all fine, we're healthy, but sometimes we develop autoimmune diseases because our immune system is too activated, and there are many receptors on the surface that help turn immune responses up or down. And in cancer, like we actually recognize tumor cells as foreign, and so they can, in principle, be eliminated. But often there are receptors on our cells, our own cells, that say, no, you need to decrease your activity. Right. Tune it down. And what these antibodies do is they recognize a receptor that says tune it down, and now it can't tune it down. So now you've really, amped up your immune responses, and that's made a huge difference in many types of cancer. The first one to really show promise was melanoma. And then lung cancer and many others now are treated by this checkpoint therapy, which is injecting a single type of antibody intravenously, and this antibody targets patients' T cells, and it just tells those, when it binds up T cells, it says, okay, don't decrease, use your maximum effect.
Right.
You know.
All hands on deck. Attack cancer,
right.
please. Yes.
Right.
So, great. And then let's go back in time, because you first were working with these in the 1970s. You were one of the first researchers, really, to do a lot of work. Not the only, but one of the first. We'll give you pioneering credit. And then that moved on into the 80s with some of your research there with adhesion molecules.
Yes. Yes.
And so, for the benefit of the audience, could you explain what an adhesion molecule is and why we need to know that these are important things?
Right. So for cells to move around in the body, in the immune system, they need to bind to other cells. And most of the time, our white blood cells are freely circulating in the bloodstream. But when there's a disease, that disease is localized. Maybe it's localized to my finger. It's infected. And then there are molecules that get expressed on the surface of the blood vessels there. And those are adhesion molecules, and they're sticky for white blood cells. Mm-hmm. And we have a video up in our exhibition that shows how this works. And actually, I was very fortunate to be able to discover some of the first adhesion molecules of the immune system. And then later on, we showed that some of those molecules were missing in patients. And these patients were unable to fight bacterial infections because their white blood cells were stuck in the bloodstream. They couldn't get out of the bloodstream. And so we
glue trap almost.
Huh?
Like a glue trap for a mouse on
well, the glue was blocked.
Right. Oh, okay. Gotcha.
The glue wasn't there. So
okay.
That's why they couldn't get out. So we were able to show that there were these 3 different steps required for cells to immigrate from the bloodstream: rolling, activation, sticking, and then migration. And those were mediated by 3 distinct classes of receptors and ligands. Mm-hmm. We even then turned it in. We thought this would be a great new area to discover drugs in, and created a successful company out of that.
Yeah, I'd love to talk about that company. And so what were the first diseases that you kind of tackled using your research?
Yes. Well, actually, the first ones were made the first generation of antibodies to antibodies that block T cell interactions with other cells. And those were, one was, I identified these molecules, I called them lymphocyte function-associated antigens. And one of these antibodies was marketed by Genentech for psoriasis. And then with a graduate student in the lab, we identified a molecule that was also required for cell-cell interactions. And we teamed up with Biogen. We made a fusion between 2 proteins. And we put part of our receptor on one end and part of an antibody on the other end, and that became a drug sold by Biogen also for psoriasis. And that graduate student and I actually equally shared the royalties of the drug when it was on the market by Biogen. He's now a professor at Oxford. So that was the sort of first generation drugs we created or we discovered. And then with leukocyte, that was for the migration of cells out of the bloodstream into tissues. And on that founding principle, we identified an adhesion molecule. It's an integrin, and it's selective for allowing cells to immigrate in mucosal tissues. And your gut is one of the mucosal tissues. And so beforehand, there were drugs that would just block immune responses everywhere. I mean, it was
Which is not great. by
not
the
good,
way.
like all over. But with this drug, we could block immune responses just in like mucosal tissues, like the gut. So we developed an antibody to this integrin, and it was approved by the FDA for ulcerative colitis and Crohn's disease.
Yeah.
And it is currently treating over 600,000 patients per year in the world. And the successor company, Takeda, is their largest selling drug.
Yeah, and I think it's fascinating because, you know, it's cool to think that you can tackle an autoimmune disease like that. In the case of Crohn's, where your own body's attacking your gut, and if I was catching what you said right, you know, before then, the way you treat it was by turning the immune system off, which,
everywhere,
to clarify, which is bad. We don't want that to happen.
Right.
We like our immune system. We don't like getting sick. And so I think what's kind of interesting about, you know, this application and this targeting is and I know we spoke about this before, there are new classes of drugs being developed that actually use antibodies to specifically target diseases, and they're carrying with them the medicine so that you can have lower doses of medicine.
Yes.
And I'd love to hear about this kind of drug.
Right. So these are called antibody drug conjugates. So some cancers have receptors on them that set them apart from most cells in the body.
Right.
And like Genentech developed a drug, Herceptin, to a receptor on breast cancer cells. And that was very successful. But now you can go a step further because there are cytotoxic drugs that, if taken up by cells, you know, they're lethal for the cells. Right. But if you just, you know, administer that drug by itself in the bloodstream, it'll kill all the cells in the body. That's not good.
Which is also bad.
Right. But if you couple that drug to an antibody, then the antibody targets it to just the cell you want it to go to. And you just kill that type of cell. So those are antibody drug conjugates.
Yeah, and it's just amazing to think about because you've had friends who go through chemotherapy. You know, like you can lose their hair falls out, you get all kinds of side effects. The cool thing about this class of drugs is that the antibody specifically just targets the tumor, and so you just deliver the chemo to the tumor cells. And so you have people like still walking around being able to do daily activities. They're not being like debilitated by the medicine that's treating them, which is just remarkable, I think.
It is. It's amazing. So one of my wife, Jeff Enns, and I are close friends. She has breast cancer. And like this has been going on for 20 years. And it's remarkable. I mean, the breast cancer's come back a number of times. Every time it comes back, there's a new generation drug out there. You know, so you know, the new developers are just keeping her alive.
Yeah. So I do know that you know, you mentioned your first company, Leukocyte, which was then acquired in 1999.
By Millennium, yeah.
And that kind of sparked your career as an investor. And you've invested in a number of biotechnology companies. I think one everyone here has heard of is Moderna. And Moderna, we know, makes mRNA vaccines. And this is a place where I think I talked last time that if you want to learn about epidermis and collagen, to go to TikTok. Do not go to TikTok to learn about mRNA vaccines. But I think for the benefit, I think there's a lot of confusion about how those vaccines work and why they're successful. And I'm wondering if maybe you could give us a minute to talk about it. We've set it up with the antibiotics because I know it's a crucial part of it. But how do the mRNA vaccines work, and how do they kind of train the immune system to fight disease?
Well, it's really pretty profound. Normally, in a vaccine, you have like killed bacteria, or you have like toxins that are neutralized, like in diphtheria toxin, DPT. Some of them you have attenuated viruses like polio. You know, it's a weakened virus you become immune to. But you know, always people were immunizing with the antigens themselves. But this is a way of immunizing not with the antigen, which is a protein, but in a messenger RNA, you know, in the genetic code DNA makes messenger RNA, messenger RNA makes the protein. So the Moderna vaccine gets the messenger RNA delivered into cells, and the cells, at the injection site, then take up this messenger RNA, and then the messenger RNA encodes the protein, and that protein gets expressed on the surface of those patient cells, and that's what you respond to. So, and one of the big advances was that you can change the vaccine so quickly. So as we all know, COVID mutated.
Yeah.
And there are these new strains that were, evolving all the time. I mean, several times a year there'd be, it was alpha, beta, omega, on and on. With the previous vaccine, it took so long to manufacture them. Like for the flu vaccine, they manufacture that in chicken eggs.
Yeah.
You come out with a new vaccine every year. But with messenger RNA, you really could speed up the process. You just change. You didn't have to manufacture like lots of virus in chicken eggs.
Right.
You could just change the sequence of the messenger RNA to keep up with the COVID mutations.
Right, and if you think about the price of eggs, it also brings down the price of the vaccines. And I think it's fascinating that you're kind of just basically training the body to make little pieces of virus, and then the antibodies train on the piece of virus. That piece of virus can't hurt you. And, but it's nevertheless teaching your immune system, this is bad, and so when it sees it on, the virus, this is bad, which I just think is incredible. So, well, Dr. Springer, we don't have a lot of time left, unfortunately, but I'd love to know, we're here to celebrate innovation and kind of celebrate a lot of science and technology. What's the most exciting thing for you right now? What do you get up out of bed looking to learn more about and are excited to see progress?
Well, I think one thing is I've started this Institute for Protein Innovation, which is here, and they produce a new type of antibody that is much more versatile than we had in the past. There are many new drugs that incorporate antibodies in there. There's a new type of chimeric antigen receptor T cell that can seek out and kill tumor cells. The cell works much more efficiently than the B cell, but it uses an antibody. Basically, it's a re-engineered antibody in the surface of the cell that allows it to do that. And then we have lipid nanoparticles. Those also have antibodies in them that determine how what cells take up the materials. So the antibodies just continue to give.
Yes.
They just give and give and give.
All right. Well, Dr. Springer, thank you so much. That was an amazing conversation. And please go check out his pavilion upstairs. And then also upstairs, Aru will be signing his books. So make sure that you're there and checking all of the things out. Thank you all so much for coming. And look forward to seeing you around exploring science. And we'll be back at 4 with space and robotics. So cheer for that, too. So, all right.
All right. Thank you.
Now, for welcome remarks, please welcome to the stage Prakash Arun Kundram, Chief Strategy and Transformation Officer, HP.
Hello. Good afternoon, everyone. So I want to start off by thanking Forbes and America250 for putting together this really amazing event, celebrating America's future and past and many years of innovation. This spirit is alive at HP, where Bill Hewitt and Dave Packard, not too far from here, in a small garage in Palo Alto, started this very thing that we call American innovation. And they built something new because they believed technology could change how people work. And we are proud to honor that legacy this weekend by welcoming some of the innovators that you're going to hear from in a few minutes, acknowledging the work that Forbes has done with HP Garage by continuing this conversation on stage today. So I also want to recognize the people who will define not just the past eras of innovation, but the next era of innovation. the next 250 years, if you will, not just the past 250, on how we work, collaborate, and create together. And that's why it's essential we bring things where people work with their tools and see how they can adapt to the changing world. And it is to ensure this future of work that we're building something super important and exciting at the same time. And in the middle of that, as you can imagine, is AI. AI is reshaping how we are working, and it's only getting started, I would think, at this point. And every morning, if you think about where billions of people spend their time, they wake up to a personal computer, a PC, to start creating content, to collaborate with their colleagues, and more importantly, actually do their work. And this future of work is already happening today with many of us. And imagine what the possibilities would be as we think about this in the future. So personally, I'm energized to be part of a company that through every era of American innovation, be it wartime innovation, be it the space race, or the personal computing, or the AI era, we're building this exact thing at HP. And today's frontier relationship between work and people is part of this relationship. So the workplace that you see today is very flexible, it's very collaborative, and at the same time, it's also something that we are super passionate about enabling. And what you're going to hear a little later today is to understand the future of work and to really appreciate the future of work in the most harshest of places where work happens, in space. And I'm super proud to acknowledge that NASA needs technology to actually enable these exact things in limited conditions where connectivity is non-negotiable, and being able to do this is non-negotiable. So we were super happy as HP to be part of one of the first companies to provide communication technology as part of the Apollo mission. And then today, workstations actually run on the International Space Station. And yes, even printers actually work in zero gravity in the space station. So it's super exciting to be able to actually provide technology that helps work happen and future of work happen, not just here on Earth, but in space. So with that in mind, I wanted to maybe close by saying hardware takes some of this ambition into reality. And we at HP have been super proud to be part of this legacy from a HP garage right here in the Silicon Valley all the way to space and innovating and really at the heart of it, extending human potential. So with that, I just want to thank you and hope to have a great panel discussion right ahead. Thank you.
Now for our next panel, Space Robotics and Hardware, please welcome Tali Baynard, VP, Ignite, Lockheed Martin Space, Bran Farron, co-founder and CEO, Applied Minds, McKenna McGrew, Quantum Information Lead, Deloitte Consulting, LLP, and moderator, Rich Neva, Senior Writer, Forbes.
Thank you guys for joining us. I'm really excited to do this panel. So this is a panel on space and hardware and robotics, and because of that, I wanted to start with something that I think really captivated us all, which is the Artemis II mission. So I'm curious, but for you guys, just what did you think and feel seeing it?
Yeah, so I was on business travel watching Artemis II, both launch and recovery. Both are important. Got to bring people back from space when you send them to space. And I work at Lockheed Martin, and it was fabulous 2 weeks of activities from that launch until touchdown, with a lot of NASA people just talking about the pure excitement across the whole community. So.
And you were showing me your lapel pin.
So I have my little Orion capsule lapel pin today. So long time in the coming.
That's great. Grant, what did you think?
Well, I was proud and excited for the United States and for our planet, and bewildered at why we waited 50 years to do it.
McKenna?
Yeah, I was going to say what really strikes me is that it's the first, expedition to send people into deep space in over 50 years, and I find that quite shocking, and also exciting to see a renewed enthusiasm for human space exploration and working towards like sustained infrastructure in space.
Yeah. And we'll get back to space, but I wanted to jump into some of your expertise. A quick poll for the audience. How many of you guys have been to Disney World? How many of you guys have ridden the Tower of Terror? So, Bran, before you started Applied Minds, for several years you were an engineer, an Imagineer, and you helped bring to life classics like the Tower of Terror, Test Track. And I'm curious, what excites you about AI today and robotics and kind of what it can do for entertainment?
Well, I think AI is one of those rare, amusing examples where simply applying vast amounts of money actually made it work. There aren't many things like that. My professor at MIT was Marvin Minsky, considered one of the fathers of AI, and our sense then is it was about 5 years out, and it has been every 5 years since then, and then all of a sudden it happened. So I think that's a surprising wow that caught a lot of people, such as myself, a little bit by surprise, because there are so many of these things which are supposed to happen soon and don't. At the same time, when you look at it for the entertainment industry, how is it going to help in creating worlds? How is it going to enable people? How is it going to enable young, creative people, filmmakers, architects, all other forms as an empowerment tool is great. Obviously, concerns about people losing jobs and such. My attitude is I think it's sad when anyone loses a job. However, a lot of the jobs that AI is going to replace, certainly in our industry, are sucko jobs that people don't really like doing anyway. And if you look at, for instance, in an IT enterprise in a typical corporation, how many people are doing really silly stuff that machines should just do on their own? I think it's exciting to see people doing more creative and productive things than dealing with COBOL and a whole bunch of other things that we thought would be gone 40 years ago and are still with us.
Yeah. Tali, you're a pioneer in LiDAR. First, can you explain LiDAR to the audience?
So if you take a photon, which is essentially light, and you shoot it out at something, it's going to bounce back off and come back, and you're going to measure how much time it took, and it'll tell you how far it is. It might even tell you what the composition of the material is that it bounced off of. And you use it in self-driving cars. It gives you a 3D view of the world. So I studied that a long time ago. So
yeah. Well, yeah, I think most people here, especially those visiting San Francisco, you'll see a Waymo, and that's what you think of as LiDAR. But what else can LiDAR be used in? And what are you excited about?
Yeah, so if people remember the OSIRIS-REx mission, so this was the mission to go out to the asteroid Bennu, collect a sample of that asteroid and bring it back to Earth. We use LiDAR in order to help do the navigation to the surface of that asteroid to collect that sample. So autonomous operation, not using AI, but just autonomous operation, so you didn't have an operator in the loop, allowing for safe autonomous operation.
Great. So. And McKenna, you're a quantum scientist. Can you explain quantum science to the audience?
Yeah, so quantum science and what I'll be talking about more on the quantum information side is the world that is really small. So the world that we live in behaves in a certain way. We call it Newtonian mechanics. And as you get really small and you look at atoms and molecules, they behave in different ways. They use the properties of quantum mechanics that have some unique characteristics, like the ability to be in many places at the same time, the ability to be both a wave and a particle, and to be entangled and correlated with each other across space and time.
Mm-hmm. And, we talk about quantum, and there's a lot of hype. There's also a lot of reality of things that it's actually doing right now. I'm hoping can we kind of separate that? Like what is actually working right now and what is like far away?
Yeah, so we've had operating quantum computers for 10 years. We call these noisy intermediate scale quantum computers, or NISQ. And they've been around, you can access them through the cloud. And the problem is that the noise really prevents the operations needed to actually do the big applications, the grand applications, to be able to solve intractable problems, to process data exponentially faster, to discover new science. And so it's really touch and go with being able to show what people call quantum advantage over what a classical computer can do, because our algorithms, even for high performance computing, are getting better and better and better as well. So what we're looking towards, and what we are kind of discussing in the back, is this next generation of quantum computer, something that is resilient to errors, something that can perform more operations, and we call this fault-tolerant quantum computing. And we expect that these next generation of quantum computers, which has taken a tremendous amount of engineering and algorithm work to get to, are going to be able to push the boundaries of what even our biggest supercomputers on Earth are able to solve.
Mm-hmm. And I am curious, you guys, your companies have been here longer than a lot of the startups that I cover. I cover AI, and so a lot of the companies I cover have been here for 1, 2, 3, 4, 5 years. Your guys' companies have been here for decades and way longer in some cases. Yep. I'm curious what you think of this moment in AI and how it's different from past moment, the Web 2.0 and things like that.
Yeah, just for so Lockheed Martin started in both Northern California and Southern California more than 100 years ago.
Yeah.
And those companies existed because you had mechanics that could build stuff that nobody else could build. So it was all hardware centric. Now as we go forward and AI is changing how we're going to be doing design, we're going to be able to do design iterations much faster. You'll be able to optimize those designs at a fairly low cost point. Still needing people in the loop in order to manage the AI elements of it. But how can you do new product development much cheaper than we ever have? How do you do customized work for each of your clients? So it really will speed up the ability to deliver real capabilities to unique users.
Mm-hmm. What do you think are the big challenges that we were talking about this on our call. This is such a big and important technology. What are the grand challenges that we as a society should tackle? Like what is worthwhile for us to go for? Brand, maybe you could start.
Well, I think that before you address the challenges of society, how about addressing the challenge of yourself? You're going to wake up in the morning and you're going to do something. Yeah. What is AI going to do to you, for you, or with you? And so it starts with that. And as a tool for creative empowerment, for example, simply doing search, which is AI assisted, I can now find in 10 minutes by using a dozen different AI search tools what would have taken me days to find before. And in fact, I've gone back and looked for things that I've spent days looking for. For example, obscure articles in a journal that I read 40 years ago. And trying to find that conventionally versus AI is the difference between waiting 15 seconds versus spending days. So on a fairly fundamental basis, for the same reason the internet became, for me, followed by the world, an intelligence amplifier. Smarter, right? You always have a joke. You can spell correctly for the first time. You can find things that you're missing, etc. That gradually takes over your process and how you think about the world. And the same thing will be happening with society. There'll be early adopters who learn and understand it first. There will be people that are threatened by it who are going to wait for the whole AI thing to blow over, just like they waited for the whole computer thing to blow over. They will probably be disappointed. And so in the whole scheme of things, I think we all as individuals need first to learn how does this impact our lives personally, the lives of our families and our workplace. From my perspective, we've had great rules of thumb over the years, such as Moore's Law, which basically, rule of thumb, you'll get twice the computer power in 18 months. Gordon Moore was talking about transistor density, but we interpret it to be computing power. And if you take algorithmic efficiencies, et cetera, instead of running for 3 to 5 years, which is what people thought when he first proposed it, 30, 40, 50 years later, the notion is it's still effective. And in fact, companies like Intel for years were driven by keeping pace or beating Moore's Law, just as their ethos. If there's a Farron's Law, it's that humans are not driven by Moore's Law, and that the same things that matter to us, such as safety and family and love and companionship and shelter and the ability to be safe in a challenging or dangerous world, they're constant. So I think as we look at the impacts on society and on individuals, you're always going to be weighing on one level rapid advances in technology, which are usually step functions. They're seldom linear. And we're seeing the step with this as it's happening now, just as we saw the step with ubiquitous wireless communications, with high-performance computing, et cetera. At the same time, people are the same. And so how does this affect this? And then how do you get together so that it works to the benefit of you as individuals, your family, your country, your society? And that we will be learning over the next 5 to 10 years.
Yeah. McKenna, how do you feel?
Yeah, I'm going to change my response. I had something planned for this, and I was going to talk about sustained energy and advances in science to actually get, sustained renewable energy. But something that came to mind as what you were talking about, fundamentally how AI is changing how we operate. And this comes to my mind with quantum computing as well as AI, but it's accessibility. So I think a grand challenge for humanity is to provide access to these new technological tools so that you don't see bigger distances occurring between different societies. So I think about this a lot, the ability to have an internet, the ability to actually connect to a ChatGPT, and I think that should be a grand challenge and something that should be considered as we rapidly, and I think with greater acceleration, progress into this technology future.
We began talking about space. I'm curious, how do you guys think the space industry has changed over, the last decade?
It's grown in size. So space was a very limited number of companies that participated as a prime, even though there was a lot of companies that supported it from an industry perspective. But the relatively easy and affordable access to space and all of the components, hardware components necessary to survive in a space environment is much more accessible. It is lower costs associated with that, and that's really changing how space is being used and the demand signal associated with that. Connecting the world, protecting the world, and a lot of people participating in different ways. Changing how those things are acquired, not just by the government, but from a commercial applications also.
Yeah. One thing that's been kind of in the news lately is the idea of putting data centers into space, which sounds like a very kind of sci-fi thing, but it's there are companies that are trying to make it happen. I'm curious what you guys think of that and how that might actually play out.
Generally speaking, I think space is the worst possible place to do something if you have any alternative, because it's expensive, it's a hostile environment, et cetera. When the space business started, it was not people, it was countries, and it was elitist by that definition. Fred couldn't decide, I'm going to build a satellite and launch it. It wasn't possible. That bred a generation of what I would call big aluminum. It's kind of the equivalent of big iron in computing, big aluminum for space, where there was a mindset where this is the only way to do things. And the idea was big billion-dollar satellites and non-reusable launch vehicles and a whole collection of things which everyone was singing off the same sheet of music. That has been inverted. Right now, you have companies like SpaceX and Blue Origin and 100 others who are saying there are better, more cost-effective ways to do space. Their calculus has been the opposite. In fact, that reusability is the only way to make space economically viable. NASA still isn't convinced. Artemis is not reusable. And so The challenge becomes everyone thinking one way because that's the establishment is now threatened in a very healthy way by people thinking alternatively who actually have the resources to execute it. So I think it's a very exciting time to reinvent the business of space, and therefore, as a protracted answer to your question, when people come with ideas like, gee, I'm going to replace cellular phones, I'm going to replace broadband fiber optic by space-based systems, that would have been ludicrous 10 years ago. It's now happening all around you in an interesting and compelling way. The idea of a data center in space, I think there's still major challenges, radiation, cooling, et cetera. So it's not trivial, but the fact is it's something which one now should be taking seriously to evaluate, where again, 10 years ago, if you'd proposed the same thing, I would have said, save your money.
Mm-hmm. What are the pros of it? You know, those are the cons. What are the good things?
Well, you've got free power and a lot of it, and it's over places you might want to use it, which is, you know, a handy set of combinations. But obviously, as compared to how do you cool massive multi-megawatt installations in space is a lot more challenging. The size of the solar arrays and what you need to get these on orbit. Having the right sort of fault-tolerant, software-definable architecture so that you can reprogram them from the ground as things change. All of that are significant engineering challenges. I mean, I think the challenge with so many of these things, and this includes multiple grand challenges, fusion power, et cetera. In fusion power, you get to a demonstration of break even, and there are a bunch of people saying, we're 5 years away from commercial power. They apparently are not the ones who have to engineer it and actually build the systems that deliver those capabilities. The same thing for these. I think you're going to see an evolutionary process where there are going to be a variety of applications, by the way, including military space, where having on-orbit compute facilities in the neighborhood with a lot of computational power will be incredibly useful to people who have early budgets that can actually pay for the delta between what a ground-based installation and a space-based installation would cost.
We're coming up on time a little bit, but I want to ask about robots. I think a lot of us here grew up with like Rosie from the Jetsons and C-3PO, and that's kind of how we think of robots. When are those coming? When are humanoid robots coming to us?
I think in like 5 minutes. Right?
When are they going to be in our homes?
Yeah, the right around the corner, I think.
Yeah.
5 years or less.
Yeah, I was going to say I agree. I got to go to NVIDIA GTC a couple years ago, and Jensen brought these robots out onto the stage and how they were interacting with them, and it was actually quite shocking. And you were interacting with robots while you were there, and you're like, wow, this is not a thing of tomorrow. This is a thing of today, and it's a matter of accessibility and affordability, but I think they're already here.
Just like your flat screen TV, right? It's like when those first came out, people said, you're going to have one of those in your house. Now you got more than one, right?
Got one in my pocket.
Yeah. So robots right around the corner.
Well, and I think the time has come in the program for you to fess up that you were in fact a robot.
I mean, that was supposed to be for later, but yeah. Quick lightning round, just while we wrap up. How are you guys using AI in your daily lives? Like, what's a surprising thing that you're using?
I use it for research science.
Yeah.
So I use it to go and work through ideas and prototype ideas in code at a rate that I never thought achievable, and I see just rapid progress in the execution of ideas and the iteration of ideas that would not have been achievable, would have taken a year-long cycle.
Great.
Same thing McKenna said.
Yeah. Well, we're at time. I just want to thank you guys for joining us. Do not leave because we actually do have robots coming out right now. So stay tuned for that. Thanks.
Now for a special Ultimate Bot Spotlight, please welcome Xenia Bulatov, CEO, Ultimate Fighting Bots.
Hi, everyone. My name is Xenia, and I'm a co-founder and CEO of Ultimate Bots. A few years ago, it would have been science fiction to imagine robots battling on cages or performing on a stage. and today is the reality. At Ultimate Bots, we're building the world's first humanoid sports league, where teams program and pilot the robots across different disciplines, including martial arts, dancing, and soon many more. We started as an experiment in the basement of San Francisco in July of 2025. And since then, we've done 7 big shows here in Los Angeles, Las Vegas. Our pilots were famous content creators, athletes, and artists. And we fascinated millions of people online. And the question is, why now? In fact, we live in extraordinary times. Robotics is now transitioning from labs and factory floors into public spaces, workplaces, and soon our homes. And robotics is bound to be the biggest consumer tech category. And with that, an important question comes to mind. How do we shape this technology responsibly, openly, and in a way that it's actually embraced by society? And we believe that competitive sport is the answer. That's why we created Ultimate Bots. There are 3 main ways in which we help advance consumer robotics. First, sports create standards. What Formula 1 did for automotive industry is now needed for robotics. At Ultimate Bots arenas, we pressure test robots and make them more reliable and safe through continuous research and development. Second, a physical AI, the brain within the robots, is a young field and it's evolving very fast. There are constant new models, new testing frameworks, and new architectures, but no common framework for evaluation. And at Ultimate Bots, we provide a live test bed for physical AI and robotics to be challenged across motion, coordination, and interaction. But it's not only about technology. In order for robotics to be truly embraced by society, we need cultural adoption. We need people to feel curious and feel inspired. We need new heroes, new stories, and new ways for humanity to build a relationship with machine that is beyond fear and abstraction. And that's why Ultimate Bots exist. We are a live test bed for physical AI and also a new breeding ground for new talent, new teams, and the new generation of robotic pioneers. And also, it's never been easier than now to build in robotics. At Ultimate Bots, we recently launched a new tool called Ultimate Bot Studio that allows anyone, including you, to train a humanoid robot motion. You just take a video of you moving in a space and upload it on our website, and then we put it on a real robot, and robot can move here in real life. We're also excited to announce the first season of Ultimate Bots that's just launched 2 days ago. The season is powered by Innovates, the ultimate physical AI cloud. The moves that you will see robots perform were trained on Innovates cloud. Throughout the season 1, we will have 3 big events here in San Francisco Bay Area this summer with fighting, dancing, and many more sports disciplines. So if you'd like to join us, please go to our website, and there are ways how you can get involved in the league. And now, to give you a little glimpse of what Ultimate Bots is, our team and Cricket has prepared a little dance performance for you. So without further ado, please give it up for Cricket. Thank you, Forbes. Thank you, everyone. We're excited to have you all at our booth, and enjoy the rest of the day.